One good day, Algebra. Joey, we're recording. Joey, warning for you. I just said we're recording. All right. Yesterday, we went from slope-intercept form to standard form. And we talked about the quirkiness of particularly that step 2. Today, we're going from standard form back to slope-intercept form. Okay? And luckily, if you understood what we did yesterday, this is kind of going to go follow line because it's really just the opposite. Okay? If we're starting with both x and y on the same side, and our goal is to get to slope-intercept form, which is y equals mx plus b, what are we going to do first? What are we going to do first, do you think, Alex? We're going to put x back, right? Our first step for this is the same as it was to put it in standard form, which is move the x term to the other side. Other side using what?
Opposite operations.
Opposite operations. Whenever you move a term from one side of an equation to the other, you're using opposite operations. Whether it's to solve for a variable or to convert the equation or whatever. Move x term to other side using opposite operations. Okay? So, this first one, we're going to subtract 6x from both sides. And the temptation here is, students generally can remember, when they move an x term over to be with the y term, not to combine them because the variables are different. The temptation here, a lot of times students will put 8x, right? 14 minus 6x must be 8x. Why can't you combine those? Why can't you combine those, Catherine?
They don't have the same value.
Right. Again, they're not like terms, right? One has an x and one doesn't. And we want to get into slope-intercept form, which has that constant, that b term. Okay? So we're going to stick this negative 6x before the 14 because we want mx plus b. So 2y equals negative 6x plus 14. It's negative 6x because we subtracted it. We moved it over using opposite operations. And it's going to be a positive 14 plus 14 because that was the sign of the 14 in the equation. Okay? What do you think we're doing next? What do you think we're doing next? We're not done because slope-intercept form is y equals mx plus b, not something y equals mx plus b. What do you think, Joey?
No.
Okay. Jack?
You divide 6. Nope, sorry, 14.
Well, you're right. Yes. By what? What are we
I
dividing by?
divide 6 by negative 2.
Okay, you're like 55% of the way
Wait,
there.
no, I know.
Claire?
You divide the whole side of the bracket by 2.
Yes. Divide every term. Yesterday, remember we multiplied every term? Now we're dividing every term by the coefficient to what? We are dividing every term by the coefficient to y, which in this case is 2, right? So we're dividing by 2. I'll do this in red actually so you can see it's an action step here.
What's the word before y?
Coefficient.
2.
Oh.
Sorry. 2. Why? And so we're dividing everything by 2. So divide by 2 there, divide by 2 there, divide by 2 there, right? We have to divide everything, otherwise the value of this equation is going to change. Okay? And so on the left side, 2 divided by 2 is 1y. We got y by itself. Okay? Our x term, negative 6 divided by 2 is? Negative 3.
Plus 7.
And 14 divided by 2?
7.
Positive 7.
Or negative 7.
We are back in slope-intercept form. Okay? Yeah, Roland.
Does it matter if you move like the 6x like before?
Dividing?
After you divide?
No. So these two steps, and really the same can be said for going to standard form. These two steps are interchangeable to where if you see that you're going to need to divide by 2, because that's your coefficient y, you could do that first and then move your x term over. Okay? The important thing is you just got to remember to divide every term by the coefficient to y.
Yep.
Okay, every term by the coefficient to y. Yeah.
Okay, so I like. I don't know how to say this. What if you like can't divide every term by the coefficient?
Because you end up with a fraction. You mean?
Uh,
Like, are you looking at this next one?
Or, yeah.
Okay. So are you asking if you can't divide because it doesn't go in evenly?
Yeah.
Okay. So remember here, we are dealing with slope-intercept form, right? And oftentimes, as we saw when we worked with slope in previous objectives, what type of number is that m? It's oftentimes a fraction. So if something can't divide evenly, that's okay, because we want, well, we don't necessarily want, but that's likely going to be a fraction anyway. So for this one here, we're going to start by moving our x term over, adding 12x, okay? That's going to give us a positive 8y equals positive 12x plus 56. Again, we put that x term first because of how slope-intercept form is written, right? The x term comes before the constant. It's positive 12x because it was negative on the other side originally. And we can't combine 12x and 56 because they're not like terms. So what Catherine's asking here is now, seeing that we have to divide by 8, I have set this up so that your y-intercept will always work out evenly. You should always get a whole number or an integer answer for that third division. You know that this first one is going to get y by itself, so that's never going to be a problem. But if you get something like 12 divided by 8, again, slope is a rate. It's a fraction. What's 12/8 in simplest form?
12.
Oh, well, I had a question.
Say it. Fred?
No.
3 over 2.
3 halves, or 3 over 2. So your answer would be 3 halves x plus 7. Okay? 3 halves x plus 7. Why wouldn't you want to put a decimal here? Why wouldn't you want to put 1.5 x plus 7? Alex, what do you think?
Boring question.
Okay, save it. Kylie?
Because slope is always rise over run.
Right.
It has to be run.
Slope, by definition, that rise over run, okay, how the line moves across the corner plane, 1.5 doesn't really tell us that, right? So we want this written as a fraction so we can see that change in y over change in x. If it doesn't divide evenly, that's okay. It can be a fraction anyway. All right, Rowan, you had a question first. Go ahead.
You answered it.
Excellent. Alex,
What is people 1 over 1?
1 over 1x? That's okay. If you end up with a 1 over 1 slope, you can put 1 over 1x, or you can put 1x, or you can put just x. All three of those things mean the same. Yes?
1 and 1 half.
Sorry, it's a mixed number.
Yes.
You would not want that either, because a mixed number doesn't really give us that rise over run.
And you can turn that into a fraction too.
So your answer should be either an integer, if it works out evenly, or a fraction in simplest form, improper or proper. All right, other questions that you're coming across? Maybe you've worked ahead and you've come across one that's particularly intriguing. Kylie? The next one, what's intriguing about that one?
The negative y.
Okay, so our first step, move that x term over, opposite operations, subtracting 4x from both sides. That leaves us with a negative y on the left and a negative 4x minus 3. It's a negative 4x because we subtracted it to move it over. It's a negative y because this subtraction sign belongs to the variable. And it's a negative 3 because it was negative 3 originally. So it's a minus 3. Claire?
Do we just divide by, or do we just divide a negative symbol? So,
Kinda, Arlene.
1 is the coefficient.
So when you've got a negative y like that, the coefficient is a negative 1. So what Arlene said, by dividing by negative 1 is correct. What Claire said about, are we essentially just dividing by a negative symbol, meaning just the sign of everything change? Yes. Okay. We do need y to be positive, so we are going to change the sign of everything. Positive y positive 4x, positive 3. Mathematically, what you're doing is you're dividing by negative 1. Okay? Because that's that coefficient to that y variable. Excellent. Excellent math intuition. Means mathematical sense. You've picked up on it.
Nice.
Okay? Others you've come across that you want help with, have questions on. Yes, sir.
Can we just do the next year by ourselves?
We can run it back. Is that a cool phrase to say?
Yeah.
Let's run it back.
Fix it.
Run it in.
Okay?
Thanks, Will.
Before we do that, any other questions? Rowan?
I was wondering if I could get
I don't have actually I do. Yes. When we pause this before we run it back, I'll
Can you stop?
get you one. Okay? All right, work on the next 3 on your own, and then whoops, that's right. I got it right here. And then we will run it back.
Stop saying that.
I'm just trying to fit in. And we are back to run it back. All right. These 3 here. Whoops, 3, 2, 1, you are quiet. Tell me your first step for the first one here. 2x minus 3y equals negative 15. What'd you do first? William.
I changed to so divide everything by one.
So you decided to divide first.
Well, first I made it 3y equals 2x minus 15.
Okay, so a couple things to watch. You really need to pay attention to signs, because when you subtract this 2x, right, not only is the y term going to be a negative 3y because it's subtracting here and that sign belongs to it, but then when you move that negative 2x over, because you're subtracting it, it's going to be a negative 2x over here. Okay? So if I heard you correctly, you said positive 3y equals positive 2x minus 15. Both those signs were incorrect. It's a negative 3y because of the minus, and then it's a negative 2x because we're subtracting it. So really pay close attention to the signs. That's the thing that's going to get you. So then our second step here would be to divide by negative 3. That's going to make our y term positive on the left side. And then a negative 2 divided by negative 3 doesn't divide evenly, but we don't care. What does this simplify to be? Ellen?
2/3 x.
Positive 2/3 x. Okay, a negative divided by a negative is a positive. So positive 2/3 x. And then what's our constant? Damien? Plus 5. Okay, y equals 2/3 x plus 5. Right? Alex? Okay. I'm going to save the next one for you to do for homework so we can correct it tomorrow. Catherine?
Can you have for the passes 3, 4, 7, and 3 of that one? Can you have a fraction as part of your
As your slope?
No, as part of your standard.
No. Remember, standard form cannot have fractions. So that's where step 2 comes in, right? If you only have one fraction, you only have to multiply by that denominator. If you have 2 of them, then you have to go to the least common multiple. But yeah, standard form cannot have fractions. Cannot have fractions or decimals. Kylie?
Also looking at the 4, 7 and
Yeah.
-3. Does the x and y variables have to do they have to be positive? Like the x variable?
When you're in standard form?
Yeah.
So it's like a negative something x?
No, it's just negative x.
Oh, negative x is fine. That just means you have a negative 1x.
Okay.
Yeah, I think I answered your question right. Yeah. As long as you don't have any decimals or fractions, and x and y on the same side in standard form, you're good to go.
But I can be a fraction.
What's that?
I've never told you.
Never mind.
In Slope-Intercept form, you can have fractions. Standard form, you cannot.
Wait, so this right here, the bottom part can't have fractions?
Correct. Because you need to put it in standard form.
So,
That's your final answer.
so you have to do the multiply thingy?
Yes. Yes. And for each of these, you should only have to multiply just by the denominator because all of our y-intercepts are integers, spirit of Christmas. Okay? All right. This is going to be homework for tomorrow. tomorrow we will graph and have a grand old time.
Yeah.
That's IMath, folks.
Don't forget to like and subscribe.
Gotta remember to come over here. What a
Oh my.